Yeah, welcome. Welcome to the talk Stopping Entropy using ArchUnit. My name is Alexander Schwartz and I'm a principal IT consultant at MSG. This is the agenda for the next about 30 minutes. We talk about, or I talk about, you ask questions, about the conventions we have in projects, discoveries we make as programmers and how we handle that in projects, how ArchUnit can help us in these scenarios, and how we can automate rules for naming, for structuring, and also for other conventions using ArchUnit. How do we ensure that the rules that we write, that they are actually working the way we expect them to work, and the limitations when you should not use ArchUnit at all, and when you should consider using ArchUnit. And then a summary for my projects and how we used it there. All right. That's the next half an hour. Please do ask questions in between, and I'm happy to answer them during the talk. Conventions and discoveries. Well, we're programmers, and we are trying to make sense out of code. And, well, once upon a time, we had this code snippet here. It was a Spring Boot application with some JPA. And that's a modifying query. So we want to do a bulk delete of some entities in the database. And you can add this. We heard this add modifying annotation in there, telling him, okay, whenever something is modifying directly, we should put an add modifying in there. But it wasn't working the way we expected to work. In a special sense that whenever we deleted something and we were still able to do the find by ID and we looked up the things and yeah, something didn't work out correctly, was flushing some kind of entity, context stuff, whatever. But we added this add modifying in there. What's happening? And we took out some time to find out, well, yeah, you need to add something. By default, it's doing nothing. It's a very useful annotation, but you need to add at least one of these two properties, telling it either to clear automatically or to flush automatically, as one is the one before and one is the one after. I can't tell them apart. So you better add both. But then, as a post-mortem in our team, we came up, well, yeah, we wasted some hours here, and we want to do better next time. So how can we prepare ourselves? How can we prepare to be not trapped again by this problem? And, well, at least there are two options. One option would be write it in the Wiki. A Wiki page where you have the package conventions and everything. Write it down here, put it to a checklist of code reviews, and, well, fingers crossed we won't slip it too often. And yeah, that's one option. The other option is, well, do an automated check. And this is what this talk will be about. An automated check will tell us what rules that pass, where we didn't make this mistake again, or as soon as we put a snippet of code into our code base that will fail this check, it will turn red, and we will notify it, well, you should add these two properties to this annotation, right? So I'm more an automation guy, but if you're more skeptic, I invite you for this little journey to find out, well, how much effort is going to be to add a rule for this discovery we just made, how to securely or safely use this annotation add modified. And the tool we are about to use for this is going to be ArchUnit. ArchUnit, it has a nice logo. That's a good start. But it's just another Java library you add to your project, and you add it only to the test scope, so it's only there during build and test time, but not in production. So that's a small start, makes people quite comfortable to edit. And then I can start defining rules. I can define rules about package structuring, I can define rules about class naming, about dependencies. All that I can define. What we see in a second. And then I can execute these rules. I can execute them standalone, calling some Java classes. But more often I see it being used in JUnit 4, as JUnit 4 test cases or JUnit 5 test cases. All the examples I will show in a minute will be based on JUnit 5. And another good thing about this tool, it's an open source tool. It has an extensive online documentation on the web you can browse, and if something is missing, you can open a pull request and have it so that's being added. I'm just a happy user of this tool. I'm not the one who actually wrote it. It was Peter. He's doing a very, very good job on this one. Yeah, but I'm just a user, a fan kind of, and showing you how we use this tool in our projects. How does it work? So, as I said, ArchUnit is run then by JUnit, and it takes the class files, or the bytecode that's in the class files, and analyze it, and it takes also the rules that we wrote them as part of the JUnit tests, and, well, it spits out a list of violations. Right? That's what we would expect from something that is checking architectural kind of rules. And whenever there's a violation, there will be a test that fails, and we can look more details about why this failed and how we could correct our code. That's the idea of ArchUnit. So let's give ArchUnit some challenges to find out how a project can benefit from this. And, well, challenge number 1, let's do some naming conventions about classes. So if you're doing a Spring Boot application, you have these add configuration annotations all over the place, and I sometimes tend myself in a place where I start to abbreviate class names. I write, it's not no longer a configuration, but a config, and then maybe becoming a conf, and so I'm, well, getting it all inconsistent all over the place, and yeah, I'd like things to be consistent. So let's write an ArchUnit rule to ensure that all the classes that are annotated with add configuration are also, well, having a name that ends with configuration. Yeah, and then write a unit test for this. And as we are in Java, well, there are some new annotations. So the first annotation you see here, that's going to be analyze classes. Analyze classes tells ArchUnit what classes it should analyze. So we give it a package name, and all these classes in this package and in subpackages will be analyzed. We can also analyze, restrict this analysis. Sorry for that. To specific classes in my project structure. I, for example, want to analyze only production code, not my test code, right? And then I start writing a test, an arch test. I annotate this with arch test and not with test as a standard unit test. And then I write down a test with a Fluent API. A Fluent API that reads almost like the rule that I tried to formulate in the first line. It says, classes that are annotated with configuration should have a name matching configuration as a regex, right? And to prove how this is actually working, we go to live demo mode now here. Let's see if the demo goes with me. So I have a Fluent API, classes that are annotated with configuration class should have a name matching a regex, right? Yeah, configuration. All right, here we go. And I can also put because I like to have it, well, consistent, right? I can run this IDE from the command line with my Maven or Gradle, whatever, but I can also run it from my IDE. And, well, it takes a second to initialize this, and within 300 milliseconds, so that's only the first test, that's a bit slower because it passes all the classes, all the subsequent tests will be a lot faster than 200 milliseconds. It shows me a violation. It shows me a violation telling me, yeah, so the classes that are annotated with blah, 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 was violated, right? And it also shows me the class that's violated. So I navigate to this class, I rename it, configuration. I refactor it, and I run the test again, and now the test passed, right? So that's what this tool is about. So with this, with this Fluent API, I get very descriptive rules. I get a descriptive error message because of the matches that are part of ArchUnit. And it will say, challenge 1 completed. Let's go on to challenge number 2. Who has layers in his or her architecture at work? Yeah, some, okay. So this is also a layered architecture. It's an onion architecture. All the outer layers are allowed to access the inner layers, but not the other way around. You have adapters to several surrounding infrastructure and other systems. The adapters can access all the other classes, but must not access each other. So that's the idea of an onion architecture and the ports and adapter thing. And the goal is to make things more testable, that you can also exchange adapters, version them more easily. So that's the idea behind. But it all boils down to do, in the end, dependency injection and putting the right class in the right package. Right? And well, if I do my work and a colleague reviews my work, and it's nothing more embarrassing if I ended up putting a class in the wrong package during code review. So I like to have that checked before, and we use ArchUnit to do this package check, and if I put the right classes in the right packages, and if they're calling themselves on the right way. So that all the dependencies go only from the outer to the inner. So again, this is our rule. And I can start with, let's start with the adapter rule, right? No adapter must access any other adapter. Again, ArchUnit provides me with a Fluent API. It's a Fluent API where I can, again, write an arc test and slice my classes by package name. I start with a slices rule definition. I slice by a matcher. So all the adapters will be identified by the package name that comes right after adapter. And, well, they should not depend on each other. Okay, that's done. Let's go on to the next challenge. I can do the slicing, that's quite handy, but I can also give names to different packages, give names to package scopes like this. So I can define a layer adapter that is identified by a specific signature of all the packages that should go into this layer. I define a layer for adapter, and I define a layer for application. And then I can again specify the constraints here. Like adapter may not be accessed by any other layer because it's on the outside. And application may only be accessed by adapter, but because that's the only thing that's, well, outside of it, on the outside of application. Again, I do have a Fluent API, so that gives me auto-completion for that. Looking at the time, all right, let's do that on the second thing. Forbidden use of classes. I trapped myself in situations where I copied code from another code base, and I kind of, well, had the wrong logger in there. So if you have a rule in your project saying you should not use Java util logging, write the ArchUnit rule for that. The ArchUnit rule here is shorter than the others because there are some general coding rules that come with ArchUnit that can be the basis of your own rules. You can look them up, how they evaluated. And, well, let's find out how this works here, what we have here. General coding rules. So I have here lots of rules that you can imagine, like no classes should access the standard output streams. Your classes should not throw generic exceptions. You should not use Yoda time if you're using a Java 8. All these rules are already there. You can inspect them by going to the source and learn about how the API of ArchUnit works and define your own rules if you want to, or just use them as they are. And the only thing you need to do is to provide a proper reason. So the violation is to use Java util logging, but what should the developer do? When he or she comes across this error message, you add a because, and this one is project specific, and again you have a proper error message that then pops up whenever this fails. Right, so that was challenge number 3, completed. Let's go on to the final challenge, challenge number 4, with this add modifying annotation that we've seen on the first slide. So each use of add modifying should have the property set to actually flush the context, so we don't use it wrongly again. And well, because I'm lazy, I would actually say, well, we set both to true, so even setting one of these is not enough for the test case I'm setting up here. So again, I have an arc rule definition. Before we looked at classes, now I can go to members, what are actually methods. All the members that are annotated with, functions or methods and fields and whatever, that's all the members of classes, that are annotated with modifying, that's the annotation we are looking at, should have modifying parameter set, so they will flush the persistence context. What I put in here is a custom condition. So this is to also prove that you can extend ArchUnit in the places where it needs to react to your frameworks that you're using, where you want to add maybe some few lines of code, and we look how this works on the second slide. So what we can do here, I'm highlighting the essential bits here, so it's basically overriding one method here, or the check method, where the Java member is passed and the events that are triggered during the check are then accumulated. So first, get myself the modifying annotation as it's been defined on this specific method that's currently being inspected. And whenever this annotation is set and this clear automatically is not set, I prepare an error message that then will appear in the build, on the CI server, on the developer who runs that unit test locally. And this is then hopefully most descriptive, like the built-in error message that I have here, and gives the developer the idea what he or she needs to fix in order to avoid this violation. All right. So now this list of this checklist, code review checklist, or list of things to read by every new developer joining the project, it shrinks. You put in there maybe only the most important things, and well, all the other things that are not so important are checked anyway automatically, and if the developer stumbles upon them, he or she will get a proper error message and learns about them as he or she needs it. But how can we actually be sure that the rules that we defined are actually working? So they're green, that green is good, right? But sometimes I wake up at nights and think, maybe I should have written that rule differently. Is it actually catching the things that I wanted to catch? Let's write a unit test for an architecture rule. And for this, we use the core API of ArchUnit that is independent of any testing library you want. And I can tell it by just using not this annotation we've used before, but by standard Java code. I want to import some packages from a specific namespace or package name that I reserved for this to show exactly this one violation. I take this one rule that I've written here and pull it out. And in the third highlighted element, the rule check, I run this classes that I know that they have violations against these validation rules, and then look, okay, do they really produce the error messages that I expect them to produce? Right. And this way I can sleep well at nights, because I know the rules that I defined are actually producing the errors once there are any errors. So that's good. Watching the watch is completed. So can I use ArchUnit for everything? And where are the limitations? So there's things to consider. Well, when you start with a new project and you define your rules in the very beginning, you don't have any legacy code that might have violation that you're not tackling at the very moment. But if you have a legacy project and you want to introduce rules, well, after a year or after 6 months even, you might want to define some exceptions that you want to handle later. So there are 2 ways to do that with ArchUnit. One would be to add a runtime annotation to the specific elements that you know there are violations and you want to clean them up later. But then you need to modify the code where the violation occurs a bit. And the other alternative is that you define some regular expressions that define, for example, some classes, some different kind of checks in a specific package with regular expressions, and these regular expressions match then all the violations you want to be suppressed. So that are just the 2 things to suppress violations: a self-defined annotation or some regexes. ArchUnit will only see information that's available in the bytecode. Yeah, but what else is there, right? But well, it will not really see Java generics, some type erasure happening there, some Java legacy. And well, if you use any annotation that have a retention policy of source, they will not end up in the class files. They will be discarded by the compiler. And well, ArchUnit will therefore not be able to check these kinds of annotations. Well, and it will also not access any non-Java files. If you have Maven dependency information, a POM that you want to analyze, you have a Git commit history, some XML, some JSON, whatever, then ArchUnit will not be the right tool for you. Maybe JQ Assistant or another tool will be something for you where you can relate Git commits to tests to, well, Maven artifact dependencies, whatever. Right. And everything we've seen today was code. ArchUnit doesn't provide a UI. There's some small part where you can draw a plant UML diagram where ArchUnit can extract some information from that and then compare that to your architecture. But in the end, it will not give you an explore view of your architecture as it really currently is. For something like this, also please have a look at JQ Assistant. But JQ Assistant is a bit of a bigger tool. It needs more experience or to ramp up. If the checks you want to do are based on class files only, you might give it a good start with ArchUnit. So, a summary. So, I see the benefit of ArchUnit that it allows a team to encode and enforce its own best practices and architecture rules. You don't need a second department, or that is either in the same building or another building, to do something for you, to encode some rules that you found as a team in a retrospective, in a postmortem, in a team meeting to be useful for you. You can encode them and ensure that they are checked from the moment you check it into your Git repository. Putting this into a Git repository also documents when this rule has been introduced. Maybe there's a commit comment, hopefully. You have a reason you add to each rule. It's almost something like of an architecture decision record, right? And the violations you see here are descriptive and human readable. You've seen them before. Yeah, you have this Fluent API. It translates to a proper English sentence. And these rules are checked as part of a usual test run, and they will fail the build. It will not be a tool with a dashboard that nobody looks at, or maybe once a month, or then once a year. It will fail immediately, and you can react on it immediately. But it will not only fail on the server. You can run it locally. You can run these unit tests before you check in. You get immediate feedback before your build server treads on your toes. And you don't need any additional server-side tools for continuous integration, because it's just a standard JUnit run that you have in your normal build. And well, I think it's more efficient than a wiki page, and worth the effort to give it a try, to be able to encode small and big rules as ArchUnit rules. Thank you very much. So we have 5 minutes for questions.
In a microservice architecture,
So the question was, in a microservice architecture, how would you centralize these rules? One way to centralize these rules to create a jar file that will then include all the rules, and this jar file can then be used by all the other projects that they just trigger this rule on the specific packages they want to have it triggered on. You can also create a test suite that runs multiple tests on these. So that's a way of, you could probably do it. Does this answer your question to some extent?
How would you trigger the execution? Because as far as I understood,
Yeah.
you use JUnit to actually run as part of the Surefire, for example.
Yeah, Surefire, yeah.
Phase. How would you trigger the execution of those?
Each team that is maintaining the microservice needs to add this library to the build, and it will need to and trigger it at part of a JUnit suite, for example. That's how we did it. You could think of it another way around, that a separate department does a test, but I think this will not really work in a microservice environment. I would rather give the responsibility to run these kind of tests to the team, and they can then probably choose to use the predefined rules in a jar file, or not, or implement them on their own if they say that's more efficient or better, whatever. So the independence to the teams in a microservice environment. Another question? Well, thank you very much.